Houston is the fourth largest city in the United States and the largest city within the state of Texas. Houston's economy has a broad business base, only second to New York City to more Fortune 500 headquarters in the city limits. Much of the city was built on forested land, marshes, swamp, and prairie, which are all still visible in surrounding areas. Flatness of the local terrain when combined with urban sprawl has made flooding a recurring problem for the city. Downtown stands about 50 feet above sea level, and the highest point in far northwest Houston is about 125 feet in elevation. Houston's long-standing nickname, the Bayou City, was adopted largely in part because of the Buffalo Bayou, the major bayou that runs from the western outskirts of the city eastward. Buffalo Bayou is the largest primary stream within the watershed and also the sole outlet for the Addicks and Barker reservoirs. Addicks and Barker reservoirs were constructed to protect areas downstream along Buffalo Bayou in downtown Houston. The bayou flows into the Houston Ship Channel, passing through downtown Houston, eventually draining into the Gulf of Mexico. It is estimated that the Addicks and Barker reservoirs will prevent average annual flood damages of $16,372,000 to the city of Houston. Both Addicks and Barker reservoir outlets experienced tremendous volumes of rushing water to control the drainage of the city. Both outlets have served Houston and the surrounding areas faithfully for over 60 years. The constant outflow and pressure that volumes of stormwater present on a year-in, year-out basis will start to create small, weak erosion pockets around the outlets where friction from the forceful flow of reservoir water is greatest. From this point, the eroded area around the drainage gates begin to increase, washing away the subbase around the outlet structure. Developed voids increase and make way for water seepage, which creates an underground flow of reservoir water. Numerous water seepage locations will continue to weaken and erode the soil, creating even larger voids, not only horizontal to the structure, but vertically as well, creating safety concerns for the performance of the outlet structure. In the spring of 2009, heavy rains caused both reservoirs to rise, which led to the flooding and closure of major roads into Houston. To err on the side of safety, the Army Corps of Engineers issued an urgent and compelling status, allowing the Army to begin the outlet restoration process immediately, a decision that would ensure the safety and performance of the outlet structures for the city of Houston. Due to the urgent and compelling status, the Corps chose URETEK ICR, a soil remediation company that specializes in stabilizing weak base soils under heavy concrete structures using a special high-density, hydro-insensitive expanding polymer.
Life vest just in case the dam breaks and water comes rushing down. We pull the deal and
gotcha. What's
for
this
the
deal
best.
right here?
Little CO2 cartridge, it blows up.
Gotcha.
When you pull the cord.
You guys ready to rock and roll?
Fixing the beam.
All right.
With URETEK operators ready to go, the void filling process begins with Addicks outlet being the first to receive treatment. Ground penetrating radar results identify where void spaces are located. Based off the GPR results and instruction from the Corps, URETEK drills injection holes to begin the process of stabilizing the outlet structure. After the first injection holes were drilled, URETEK operators discovered larger void spaces under the conduit that was initially suspected based on GPR results. Operators field tested the void spaces by inserting a 5-foot copper rod through the 24-inch thick concrete. Void probes showed 1 to 3 feet of void in many areas under the conduit. As the injection process began, large void spaces began to fill up, along with densifying and reducing seepage. As the polymer is injected, it immediately starts to expand but still travels under the conduit to the path of least resistance, filling the void and densifying weak areas.
So far we've finished tube 1, starting on tube 2, working our way toward the middle.
How are the voids underneath the tunnel?
1 foot, 3 foot.
With a larger amount of void in a time-sensitive situation, additional URETEK ICR affiliates are called in from around Texas to assist in void filling the Addicks and Barker outlets. With 2 URETEK teams void filling 2 conduits at the same time, the void filling process becomes more efficient, an asset to the Corps' goal to completion. The patented URETEK polymer expands and it is at 90% strength in less than 5 minutes, so when outcropping occurs in flowing water, the material will set up inside the outcropped hole quickly, wasting little material and creating little debris for landfill. The little material that is carried out by the current is easily captured with floating buoys. Even though the polymer is environmentally inert, the worksite is kept clean.
We set a couple of booms across the channel. There's no flow, very little flow coming out of this set of gates. We put 2 booms across just to catch the floating foam. They're not going to be opening the gates until after work on Friday, and we'll just move the booms and roll it in towards the shore to pick it up. Shouldn't have any spillage over into the waterway downstream.
Alright, we're trying to cover this seam right here, seal this seam. We've got it coming out. It came out right here. We've got water coming up. You can see the water. So we're hoping any minute it's going to come out. Shooting about, what, 10? Yeah, 10 feet, 10 or 12 feet. 10 feet back? Alright. 12 feet back and it's traveling down the floor, down the wall. We had water earlier. Shooting out of there? Water shot out, but then it stopped. Right. As soon as this shot out, this stopped. Alright.
As URETEK polymer is injected under the conduit, it aggressively seeks out void spaces and begins to tighten up the surrounding soils, bonding the strata together to increase the collective load-bearing capacity to support the structure above. The polymer quickly expands up to 15 times its liquid volume and is at 90% strength in less than 5 minutes. As voids are filled below the weakened structure, the polymer will travel vertically, filling voids along the sidewalls, restoring the entire structure's subbase, providing superior stabilization to the conduits, and drastically reducing the chances of outlet failure. Army geotechnical engineers gather soil samples to determine the condition of the base soil that the conduit was built on. Samples taken on previous injection locations showed URETEK polymer was present under the conduit and was filling the voids and densifying soils. As URETEK crews wrap up the first round of void filling that took less than a week, the job is far from over. The Barker outlet station, Addicks' mirror sister, has the same void concerns and requires the same treatment to restore the integrity of the subbase.
You realize the magnitude of what you're doing as far as stabilizing this thing to ensure the safety downstream there?
Yeah, they said if we don't, that old President Bush house have water in the front door. And he wasn't like old man Bush, he wasn't like that.
The following week, URETEK crews began drilling the initial injection holes through the Barker concrete conduits. Like Addicks, both were built in the 40s and have been modified through the decades to support the growing demands of the city of Houston. Initial geotechnical investigation showed smaller but considerable sized void spaces below the conduit. During construction of the spillway, investigatory access ports 5 inches in diameter are routinely used to check the subbase, as voids under the spillway slope are also a concern. As URETEK crews began void filling, polymer began to seek out weak soil pockets and void spaces, occasionally traveling vertically along the joints between the conduits. Material also followed void paths under the spillway slope as well, with a surprise appearance through one of the investigatory access ports, pushing loose soil and expanding through the hole.
Outcropping. I was shooting about 13 feet away, pushed up about 8 inches of mud, and then all that material was hard when it came out, so it's under a lot of pressure.
We wanted to find all the weak spaces underneath, all the voids, follow the path of least resistance, and fill this cavity up underneath there. stabilize this entire structure.
With the Houston heat starting to sliver in, crews take a quick breather. As URETEK crews wrap up the initial void fill phase at the Barker outlet location, optimistic signs such as more outcropping and tightening of the loose soil from under the conduit show big progress has been made to stabilize and fill the voids under the outlet structure. The Corps continues to monitor both outlet structures as URETEK works at the Barker location. The Corps opens the gates to the Addicks outlet station to continue relieving the Addicks reservoir of high water, an efficient plan that will pay off in case of an all too common heavy sustained rain that can cause another rise in floodwater that can threaten the city.